Our lesson in algebra this week involves solving one-step equations using addition and subtraction. As we begin, we're going to discuss what does the equal sign really mean. I'd like you to look at the equal sign like what's on this side and what's on this side are actually equal. They are the same things. Sort of look at it as like this line that's right in the middle, and this side is the same as this side. And you can see in my picture here, I have a blue bike is equal to or is the same as a blue bike. Consequently, we can see that our blue bike is not equal to the red bike for several reasons. It's a completely different bicycle. This one's red, that one's blue, this one's larger, that one's smaller. This is a symbol that we use to denote not equal to or unequal to. In the same way, we would say that kitty cat is not equal to panda bear. And yes, we might argue that they're both animals, but remember, the equal signs means it's the exact same on both sides. Moving away from pictures and looking at numerals, we can see that 3 is equal to 3, and 3 is not equal to 4. Remember, that equal sign means that it's the same on both sides. You're used to seeing problems with equal signs like this. 2 plus 2 equals 4. If we, again, take a look at our equal sign, what's on the left side is the same as what's on the right side. Let's look at our next problem. 3 times 5 equals 15. As we look at that equal sign, we can say that what's on the left is the same as what's on the right. 7 minus 5 equals 2. Again, as we look at our equal sign, what's on the left is the same as what's on the right. Because we know that the equal sign means that what's on one side is the same as what's on other, when we're doing algebra, you've got to line up your equal signs when you work the problem. This is extremely important. We didn't do much of that last week when we were working through some problems, but now I want you to focus on making sure that you line things up on the equal sign. So here we can see that 2 plus 3 is equal to 1 plus 4. The left side is the same as the right side. 5 is equal to 5. Notice how my equal signs, as I have worked those problems, are lined up. Here's another one. 4 times 2 equals 1 times 8, which means 8 equals 8. Again, we are lining up the equal signs as we work our problems. If we were to work this problem, we wouldn't just take this 8 equals 8 and put it like over here on the side. Sometimes when you work one side, you put the equal sign right down underneath it. There's 2 rules of algebra that I want you to carry with you from now until you graduate from high school and move on to college. If you remember one thing I have ever taught you, well, in this case, 2 things that I have ever taught you, I want you to remember this. What you do to one side of the equation, you must do to the other. And the second rule is that you must isolate the variable. Isolate means to get the variable by itself. Let's see what that means. Here we have a simple problem, much like the ones that we worked on last week. And we could have taken these from words and made it into an equation. But here's our equation. G plus 8 equals 11. This problem is easy to solve. We can just kind of look at it and we know that the answer is going to be 3 because that's the only thing that fits there. So we would say that G is equal to 3. Now we're going to solve this problem algebraically using the 2 rules. We take our simple equation, G plus 8 and equals 11. How do we actually know that 3 goes in there? Well, remember our first rule, what we do one side of the equation, we have to do to the other. This is where that applies. So let's take it how we can think about that. We have to isolate this G and get the G by itself so we can figure it out. So let's subtract on this side and subtract on this side, because when we add plus 8 minus 8, we're going to get 0. So all we're left is G. As we look at 11 minus 8, we know that we can say G is equal to 3. That's how we get it. Notice that I've lined all of these up as I worked the problem and worked part of it and then worked the next step until I finally got my answer. As with everything else we do, we've got to check our work. Remember that our original problem was g plus 8 equals 11. We said that g was equal to 3, so we put the 3 in there to see that it was true. Notice that all the equal signs were lined up in our problem. Also, because this was an addition problem, to solve, we did the opposite. We added. So this is the setting up the problem that I'm going to be grading on, and I'm going to be grading your ability to understand how to do this and how to set up. So please replay the video as many times as you need to make sure that you understand how to set it up. Let's solve this problem algebraically. E minus 5 equals 9. What can we do to figure out what E is going to be? Remember, we kind of have an idea of what it could be right away without thinking about it too much. We kind of already know it's going to be 14. But how do we do that algebraically? Remember, this is a subtraction problem, so we're going to add on both sides of the equation. Why do we add on both sides of the equation when it's a subtraction problem? Because we want to isolate that variable and get that variable by itself. So working from left to right, we wrote E minus 5 plus 5 equals 9 plus 5. We know that minus 5 plus 5 is equal to 0, so we just carry the E down. Remember to line up the equal signs. Now we're left with 9 plus 5, which gives us 14. And again, carrying the equal sign down. We checked our work because we said that E was 14 and inserted E in there, and we found that 14 minus 5 was indeed 9. Let's take a look at some common student errors. Our first one, B plus 7 equals 10. B equals 3. Wait a minute, Danio, you're saying, but B is equal to 3. Yes, it is indeed equal to 3, but this student is not showing their work, nor are they showing how they arrived at the answer of 3 algebraically. Let's look at what is wrong with this one. B plus 7 equals 10. Right away, you could be thinking about what could potentially go in there, but let's solve it algebraically. We did it in our original problem, what we do to one side of the equation, we have to do to the other side. This student added 7 to both sides. While they were correct in that they had to do something to both sides, they were incorrect in the fact that they were adding a 7. Remember, we want to isolate that variable and get that B by itself, and the only way to do that in this particular problem would be to get a negative 7, because a positive 7 and a negative 7 would have given the student 0. Once they moved on and just kind of went through the motions here, they figured out that B was 17. When they checked and they put 17 back in, they found that that was incorrect. Here's another what's wrong problem. The original problem, H minus 6 equals 1. In this problem, the student knows that what you do to one side, you have to do to the other. And that was great. However, because this is a subtraction problem, they added a negative 6 to both sides. That doesn't cancel out the 6's to get an H there. Because remember, we've got to isolate that variable. That gave us an incorrect answer, and when we added it back in, we knew we were incorrect. Remember, do the opposite. Here's one for you to try. I'm sure all of you can just look at that answer and figure out what it is in your head without having to do anything algebraically. But I want you to pause the video, get a paper and pencil out, and solve it. We'll go over each step so that you can be sure that you're going to do the worksheets correctly. T minus 2 equals 9 is our first problem. We noticed that this was a subtraction problem, so we had to add 2 to both sides of the equation. Remember, our first rule states that what you do to one side of the equation, you have to do to the other. So we added 2 so that when we had minus 2 plus 2 gave us 0, that left the t by itself. We then looked at the 9 plus 2 and got 11. So our final answer was t equals 11. Notice that for each stage, I lined up all of these equal signs. If lining up is something that's difficult for you, make sure that you use a ruler or something to keep yourself on board. As always, we checked and we put our 11 inside our t, and we know that 11 minus 2 equals 9. Here's our last you try it for the day before you're ready to start your worksheets. Remember to pause the video, work the problem, lining everything up correctly, and we'll go over all the steps. Don't skimp out on this part and just go to the next part of the video. Pause this video. This part is really important for you guys to know. All right, here's our original equation, r plus 6 equals 16. We noticed that this was an addition problem, so we know that we had to subtract on both sides of the equation to get rid of the 6's on this side so that we could isolate that variable by itself. We like to keep that variable on the left-hand side by itself if we can. So plus 6 minus 6 gave us 0, so that gave us r by itself. We carried our equal sign down, then 16 minus 6 became 10. So we said that r was equal to 10. We put the r back into the equation, making that 10 plus 6 equaling 16, and we could see that we were correct. Remember to watch this video as many times as you need to understand the concept. This is not hard, but it is definitely something that requires work on your part. Have fun!